we're talking about storing large amounts of water, there are standby losses. And all a standby loss is, it's like putting your coffee cup that you just microwaved on the counter and letting it sit, right? Heat is going to move in the direction of cold. So over time, you're going to lose energy in your system and you have to apply more work, more energy to reheat that system up. You see numbers floated around by us that say we save 30%, 40%, 50% on fuel savings for our customers. And the obvious question is, how are we doing that? I like to break down the difference between thermal efficiency and operational efficiency because this is really where the money gets made. Typically, when we talk about efficiency, you hear about thermal efficiency. Thermal efficiency is the effectiveness of a heater at converting input energy into hot water, essentially speaking. What you're doing is you're taking fuel, you're combusting it, and then you want to make sure you use as much of the heat that's generated in that process as possible. Theoretically, you'd want 100% of that to go to your water, but there are losses involved. And so even high efficiency systems are looking at somewhere between 94 and 98% thermal efficiency. What you're seeing here on this diagram is this is a traditional boiler sidearm system. You're seeing that the thermal efficiency gets rated for the piece of heat generation equipment here. Okay, so this is what gets included in that rating. When we talk about operational efficiency, we're talking about the effectiveness of the system at converting your input energy into hot water that actually gets discharged at the fixture. So this is a more holistic view of the system. This doesn't just take into account how much of the energy I combusted goes into the water. It means once that water leaves, how much energy do I have when I get to the fixture? Okay, so you might also hear this called cost efficiency. Conversion efficiency is another term we sometimes use. How much of the money I spend actually gets used. So for every dollar I spend, how much money am I actually wasting before I get the water to the fixture? You notice that in this system, everything is circled, right? Because everything is important in this system. If I spend X amount of money on my gas and I transfer 100% of the heat to my water, but I lose heat along the way to the fixture, then I'm still not operating at peak efficiency. And so your standby losses, depending on the size of your tank and the set point temperature, are going to be anywhere between 4 and 12%. And all of this has been modeled by telliTalk to determine how much energy you actually end up wasting in a traditional system. And so what we found is that systems that rate themselves as high efficiency systems actually might perform as much as 36% lower than the thermal efficiency that they have on the sticker. And so that means that for every dollar of money you're putting into that system, you're actually getting 64 cents of usable energy out of the system. It's almost like lighting your money on fire. So with those types of systems, you end up wasting a lot of energy.